Hello everyone. Today we will be discussing about Hamiltonian cycle which uses the technique of backtracking. So before discussing what is Hamiltonian cycle, we should know what is Hamiltonian path. What is Hamiltonian path? Hamiltonian path is a path that visits every vertex in a graph exactly once. And what will be the cycle? The starting and ending vertex will be same. That means in a graph will be given, you have to visit the vertices exactly one time, and we should end with the vertex where we have started. That means starting and ending vertex will be same. So we will discuss a problem here. This is a problem. So it has 6 vertices and it's an undirected graph. It has 6 vertices and we should find the Hamiltonian circuit or Hamiltonian cycle in this. So I'll be starting with this one vertex, vertex A. So vertex A, I'll check which are the adjacent nodes of A, B, C, D. Any of these vertex you can visit. So I'll be visiting here the vertex B first. B first. Okay. So I'll be visiting here B. Then, here I'll be visiting B. Otherwise, you can visit C and D also. It doesn't matter. But I'm going as per the alphabetical order. So B I'll be visiting. Then I'll check which is adjacent node of B. A, C, E. A is already visited. So you have two options C and E. So I'll be visiting C as per the alphabetical order. So A, B, C. Then from C, D, E, A, B is there. But A and B is already visited now, which is the left out option, D and E. So I'll be visiting D. Now, from D, you have the option A, C, E, F. A and C is already visited. So E and F I'll be going for E. So I'll list E, search for A, B, C, D, E. Then from E, the only left out option is F. So F I'll wish. But if there is any edge from F to A, you to go back? No. So that means I have reached a dead end. So what I'll do? I have to backtrack. Now I will do the backtracking. Again, if I do from F to E, the backtracking, the only option is we don't have any other options to move forward because C, B, D are all visited. So that means again I will do the backtrack here. Again, if I do the backtrack here, instead of going to E, I can visit F, right? Now, F, which is the next option left out, D and E. D is already visited. E is what? Dead end. So, again, I have to backtrack. Whenever I am backtracking here, from C, instead of moving to D, I am visiting E. Okay. Then again, E has two options to visit, F and D. So, I will be visiting F first. Now, again from F, I will be giving D. Then again, I have the option to go back to E. So, that means I got the Hamiltonian cycle here. What is the cycle? From A to B, B to C, C to E, E to F, F to D, D to A. That means I have visited the order A, B, C, E, F, D. That means apart from A, all the other vertices are visited exactly once, and I have visited all the vertices in the graph. This is the Hamiltonian cycle. Now, if you want to find another cycle, means what you have to do is again here backtrack. So again, instead of going to B, from B to C, I can go to E also, right? Again, you can continue. So E, F, D, like that you can continue. Try to find out all the path in this. This is the easiest way of finding the Hamiltonian cycle whenever you are drawing a tree form. So backtracking, always we use a tree form only. In Einstein's problem also we have discussed. Sum of subset problem also we have discussed. So in all these problems we were finding out the solution for the backtracking problem by using the tree. The tree is called state space tree. Right. So this is a state space tree. In that also you will be getting another solution also. You can get, or sometimes the problem will be having only one solution. Otherwise, this problem will be having one or more solutions. So it is your choice to stop with the current solution or not. If you are stopping with the current solution, it's fine. That one solution you have found out. But if you want to find all the possible solutions, all the possible trial of the path you can do in this state space tree, always do whenever you are reaching a dead end, always go back to the previous step and finding out in this. So here one more thing we will find out. So here this is B and E. From this path we will check. That means I have visited A and B. Now E also I visited. I'll check which is the path which is going from E. So this is my graph from E. That means A and B is visited and B and E is visited. From E, there are three paths, right? C, D, and F. So I'll be visiting here F first. So if that means what all things you got, I'll draw here A, then B, then E. This is our current situation, right? That is A, B, and E. Now, from E, how many paths are there? B, C, D, and F. B is already visited. You can either visit C, D, or F. So, what I'm doing is, I'm visiting F. That is also one path. So, F is visited, E is visited, B is visited, A is visited. Then from F, what is the path? You have two paths, E and D. E is already visited, right? So, I'll move forward to D. So, from here I got D, right? So, D is visited. Then from D, it has two options. One is A and one is C. A is already visited. It can come only at the end. So, I can visit here C. Now, C. Then from C, there is all the vertices are visited. Now, if there is any path from C to A, yes, it's there. That means from C. This is another Hamiltonian path. A to B, B to E, E to F, F to D, D to C, C to A. Understood, right? The same way you can draw another graph. See, after doing the backtracking here, instead of visiting A, I'll be visiting here. See, so from A I started. Instead of visiting here B, I'll be visiting here D first. Okay, so A is visited, D is visited. From D, C, E, F path is there. So what I'll be doing here is from D, I'll be visiting F. So F is visited. From F, I'll be visiting E. So F, E. Then from E, I'll be visiting C. F, E, C. From C, I'll be visiting B. B. And if there is any path from B to A, yes, it's there. So this is another Hamiltonian cycle. This is A to D, D to F, F to E, E to C, C to B, and B to A. That means all the vertices are visited in this, right? And starting and ending vertex is same, that is it's a Hamiltonian cycle. That means you can find n number of Hamiltonian cycle from this. Only thing is, if you want to find all the solutions, start with one path, again backtrack, try the other possible path, and if you're reaching a dead end, again backtrack, find the solution. And if you're getting a solution also, again if you want to find some more solution from this, again you have to do the backtracking technique in this. That means it's not like only one Hamiltonian cycle will be there in a graph, since it's an undirected graph. And almost all the vertices, when you see, almost all the vertices are visited here. So that means you'll be able to find out a number of Hamiltonian paths in this. So sometimes some graph will be given where you will not be able to find out only the Hamiltonian cycle. So you should know how to find out, especially when the directed graph is given. So only by using state space tree you can move forward to find the Hamiltonian cycle. So hope you understood the problem. If you have any doubt in this, you can ask me. This is another important question that will be asked in the university question paper. So try to solve out by taking different examples from the university question paper and from the different textbooks, and try to find the Hamiltonian cycle or Hamiltonian path by yourself. That's all for today. Hope you understood the problem. Thank you.